Okay, this video's about Venn diagrams. They are not commonly a question in our external exam, but they have come up, so it's better that we just look at them, do a little bit on Venn diagrams. Firstly, a Venn diagram uses circles and logic to show the relationship between different sets. An overlapping circle shows characteristics or items that are in common with both sets, and they're often used in science. You can see them sometimes. The example here is the characteristics of mammals and reptiles, and some overlap, such as vertebrates, which breathe with lungs, which both reptiles and mammals contain. Also, so on with Venn diagrams. The notation that's used, just in case you see this in a textbook, A intersect B is the first one on the left at the top, and that means just that area that's overlapping between the two sets. And upside down kind of an N kind of shape is the symbol for intersecting. Below it, A union B contains everything in both sets as well as the overlap. On the top right, A intersect B and then the complement of that. When it has a line over the top of the A intersect B, the complement, that means everything outside of A intersect B, because A intersect B is in here, and so everything outside of that is the complement. Then we have A minus B there, just in case you see that in a textbook. An example of when we use Venn diagrams, and it's always good to draw your own picture diagram of what the problem shows. So we have 100 students, and this is talking about brothers or sisters, siblings. It's almost always 2 circles, but if we're talking about things like sports or subjects that students take, it may be 3 or 4 circles. Here we just have 2 circles, one for older siblings and one for younger sisters and brothers or siblings. And 41 students have an older sibling. So it would be tempting to put 41 in here, but that's not going to work out, because that 41 includes some of the siblings that are in the middle intersecting part. So we want to wait before we work out how many that is. So we'll rub this out here, and it's usually best to start with what's in the very middle, the intersection. 41 have older siblings, 69 have younger, 25 have both. So we know definitely that 25 is in there. And we know that in this whole older circle here, set, there are 41 students. So there must be 41, take away the 25, and that leaves me with 16. The 16 and the 25 will add to 41. And I can do the same with the younger group. In this younger group, if I colour it with the green, we have younger is 69. Take away the 25, leaves me with 44 students have just younger siblings. And we were told at the beginning, so this is our larger set here, we're told that in total there were 100 students. So we've already got 16 plus 25 plus 44, so that's 85 students in the circles. So if there's 85 in there, that leaves us with 15 that do not have any siblings. Okay, so the question then, we get to the question after we've drawn our diagram. Find the probability that a student chosen at random has a sibling. So that would be, we're looking at the probability of having a sibling, brother or sister. Sibling's kind of a weird word, isn't it? Probably the sibling is going to be 16 plus 25 plus 44 is 85 students out of 100. Or we could have 85% or 0.85. And the probability of no sibling, there were 15 outside of those sets, 15 out of 100 or 15% or 0.15. Okay, but the main thing there that I would say you need to remember is to put the first number that you put in is the middle number, and then you have to subtract that off the larger circle. You don't want to count it twice. Okay, I think the next page, how we've worked that out. Probability of at least one sibling, and the probability of no sibling is 15. Going on, another example, public and private hospitals. In this one, we've got just 2 circles, and we've got private hospitals. Let's label that private hospitals and public hospitals, and some people go to both hospitals. So this is looking at 2012 statistics, a couple of years ago. In 2012, the probability that a person in New Zealand was treated in a public hospital was 0.23. Those treated in a private hospital was 0.15. Treated in both was 0.03. So again, remember putting the middle number in first. So we've got 3% in the very middle. So that means that in my private circle here, I've got private was 0.15, but I've got to take off 0.03. So that leaves me with 0.12. That should add together to make 0.15. And then if I go to my public hospital, this one here, public has 0.23, but I have to take off 0.03, that will leave me with 0.20. We have to calculate the probability a person was treated at a hospital. So we want to know the total here of people treated in hospital. Of course, outside of this would be those who don't go to hospital. But those that go to a hospital, either private or public or both, would be 0.12 plus 0.3 plus 0.20. So that probability would equal 0.35, I think. 35. Okay. See that worked out on the next page a little more neatly. And those are the only examples I've got at the moment, but you can, if you have the theta textbook, there are some problems in there, or the homework book also has some problems. Thank you.